this section you will really be tested on how well you understand graphing, and symmetry is the first thing we're going to look at. We're given the equation y equals x squared plus 3. We see the x squared, we know it's a parabola, and that plus 3 means shift it 3 units up. So I'm going to go 3 units up, there's my vertex, and I'm going to go up 1 over 1, and just draw a real quick sketch of what that should look like. I know that's kind of dorky looking. Now, is this symmetric about the x-axis, the y-axis, or none of these? And we have a y-axis here that we have a mirror image on both sides of, so this is symmetric about the y-axis. And we're just basing this upon the graph we're looking at. A function is said to be even if f of negative x is equal to f of x. Okay, now what does that mean? Well, let's take a look at an even function. Let's take a look at a parabola that goes through these standard points here. And I'm going to do the best I can to draw it there. Y equals x squared is an even function. Now, if it helps to see that the even exponent there helps it to be even, that's fine. Now, let's go a couple units to the right to an x value and 2 units to the left to its opposite, which I'll call negative x. Both of these, when you look up at the graph, go up to 2, 4 and negative 2, 4. They both have the same height. In other words, f of negative 2 is equal to f of 2. 4, the height on the left, is equal to 4, the height on the right. And it turns out that all even functions, as we have here, are symmetric about this y-axis. Now we turn our attention to odd functions. A function is odd if f of negative x is equal to negative f of x. And these functions are symmetric about the origin. Let's start by graphing our basic cubic function. Y equals x cubed is an odd function. Now, let's take a point such as, let's go over here to like 1.5-ish on the right, and left to 1.5, we'll call that negative x. And let's go up to the graph on one side and down to the graph on the other, and let's look at those y values. The height of x is called f of x, and the height of negative x is called f of negative x. Well, are those heights opposite of each other? The answer is yes. In other words, f of negative 1.5 should equal negative f of 1.5. See, f of 1.5 goes up to a positive value, but multiply it by a negative, you have the same y value down below. Now, these graphs are always symmetric about the origin. In other words, if you take 2 points on the curve, let's just take where those 2 arrows are, you can always have the origin as a midpoint between those two. If we look at the problem that we see in this next graph, we're trying to determine, is it even or odd? It is an odd graph. Notice it goes through the origin, and everywhere I look, there's 2 points where the origin is the midpoint. If I go over here to like 1.5, 5, and negative 1.5, negative 5, right there between them is the origin. No matter where I choose my points, 3, negative 3, the origin is right between those. So this is an odd function.